Hello, children. Now we are going to start a new topic of the first chapter, that is simple pendulum. It is the last topic also, simple pendulum. So this pendulum clock, it is used to measure a time. So from the simple pendulum we can measure the time period. So it works on the principle of periodic oscillations. Periodic oscillations. So just see, it is used for the measurement of time. It is very important, and we use a pendulum clock for the measurement of time, which is based on the periodic oscillations of a pendulum. The pendulum repeats its position after a fixed interval of time. So what is the periodic oscillations? What do you mean by periodic oscillation? Periodic oscillations means that any particle which vibrates in four phases, that means first it is at the mean position, then from the mean it will go to the extreme position. Initially it is at the mean position, then we have applied some force to it, we have displaced it from its mean position, then it will go to the extreme position, then from the extreme it will again go to the mean position, then again from the mean it will go to the extreme position on another side, then again from the extreme it will come to the mean position. So if you will see all together, once it is going to the extreme of other side, then coming back to the mean, then again it is going to the extreme of another side and coming to the mean. So it is covering total a four phases, and that phases we are considering it is of 90 degree. So means it is totally covering 360 degree phase, so 360 degree it is covering. So that is known as the periodic oscillations of a pendulum. Graphically you can show it. Once the curve will go up, then it will come down, it will touch the axis, it will touch the x-axis, then again it will go downside of the x-axis, then again it will return back and it will touch the x-axis. So it is a complete phase of oscillations. So if you will join these curves, you will get a circle that is of 90 degree. One means quadrant of a circle, one quadrant, second quadrant, then third quadrant, then fourth quadrant, totally it is making 360 degree phase. So in this way its working is based. So first of all we will see its basic construction of a simple pendulum. Its basic construction is very simple. There is some rigid support. From that rigid support one thread is tied, and to that thread one metallic bob is attached, and we are having this apparatus in the lab, and we will do the experiment also on this one. So that bob is attached with a thread. Then if bob is displaced from its mean position, it continues to and fro motion repeatedly, and that motion will be continuing till there will be a damping. When the forces applied that will be damped, then it will stop, otherwise it will go on oscillating. That is from the mean to the extreme, then from the mean to the extreme on another side. So in this way it will go on oscillating. So this is its basic construction, and one string is there, one bob is there, one rigid support is there. Now comes the concept of length of a simple pendulum. What should be the length that should be considered for the simple pendulum? Here the thread and other things we are considering it as inextensible and weightless. The weight of the thread we are ignoring while doing the experiments. We are ignoring the weight of the thread, although it is not a weightless. It is having some weight. The thread is having some weight, but we are ignoring that weight. And what about length? Total length of the thread plus one more length we will take, that is radius of the bob. So that means we are measuring the length of a pendulum from the center of the bob. From the center of a bob we are measuring the length of a pendulum. So these are its basic construction, how it is constructed. So some important terms that are related with this, that is from the simple pendulum. One is periodic motion, the motion whose time period is fixed or constant, or it repeats position after a fixed interval of time. The motion whose time period is fixed means a motion whose time period is fixed or constant, or it repeats its position after a fixed interval of time, that is known as the periodic motion. That you have understood well. Time period, the time taken in one oscillation is called time period. Time taken for completing one oscillation is called time period or period of oscillations. That means time required to complete one oscillations. How? If you are making a graph, you are taking x-axis and y-axis, you are just going up, then coming down, curve, then you are getting a semicircular arc. You are going up, then again coming to the down, that is joining the x-axis, then you are getting a semicircular arc, then again going down side of the x-axis, that is towards the negative side, then again touching the x-axis, so again one more semicircular arc. So these semicircle and semicircle, two semicircles comprises of one circle. So this is all together the total, the time required in moving the particles in such a manner that is known as the time period. The time taken in one oscillation is called time period or period of oscillation. So that is one oscillations. So that means two semicircles, formulation of the two semicircles will give the one oscillations if you are seeing graphically. Next one is frequency of oscillations. Frequency means, verbally also if we are talking about frequency, the dictionary meaning, frequency means how frequent anything, means in a unit time how much happening is taking place, that is frequency. एक यूनिट टाइम में कितना बार कोई चीज हो रहा है, दैट इज इट्स फ्रीक्वेंसी. So it is the number of oscillations in 1 second, and its unit is per second or hertz. It is the number of oscillations in 1 second. In 1 second, how many times of oscillations are taking place, that is known as its frequency. Suppose in 1 second, these type of curves are formed, 4 curves are formed. So its frequency is 4. Why its unit is per second? Because the unit of time period is second, so 1 upon second is per second only. 1 upon second is per second, or we call it as hertz. We call it as hertz. Okay, it is designated as hertz. Now comes the amplitude. Just now we have talked about the curve, semicircular curve, upside of the x-axis and downside of the x-axis. So from that curve, if you are just seeing the maximum displacement, the maximum distance from the mean position, the maximum displacement that is from the x-axis, that is known as the amplitude. It is the maximum displacement of a vibrating body from its mean position. So in terms of this simple pendulum, you can see bob is hanging, that bob is going to the extreme, so that is its amplitude. Again going to the extreme on another side, so that is its amplitude. So it is the maximum displacement of a vibrating body from the mean position. Maximum displacement of a vibrating body from its mean position. Effective length of a pendulum, I have told you, it is the distance of the center of gravity of the body from the point of suspension. That is, effective length equals to length of the string plus radius of the bob. Length of the string plus radius of the bob. Okay. So experimental determination of the time period of a simple pendulum. So these experiments we will do in the lab. Just I will tell you some basics of this one. So in this way you will make observation table inside your lab manual, inside your practical workbook. You will make this type of observation table. In that one you will make all these columns. So here you see serial number, there is no issue of that one. Effective length, second column is effective length. So effective length means length of the pendulum. So there is a one hook to which the thread is tied. So from that hook we can increase or decrease the size of the pendulum. So first we have taken suppose 60 centimeter, then 70, then 80, then 90, then 100. So 5 length we can take. So on 60 also we should take the readings, on 70 also, 80 also, 90 also, 100 also. So suppose we are taking 10 oscillations, it is not necessary for 10 oscillations, we can take conveniently for 20 oscillations, 15 oscillations, whatever we need. And we will record the time. So we will record the time for 10 oscillations or 20 oscillations. So for 10 oscillations, the time period equals to suppose 20 second. Suppose 20 second is the time period for 10 oscillations. So 1 second will be the time period for 20 upon 10 oscillations. So we can determine the frequency also, we can determine the time period also. We can determine the time period also. So time period equals to, that is number of oscillations divided by, so time required for 10 oscillations divided by 10, that is number of oscillations. So we can determine the time period also. Then they have squared it, so we can square it easily. So in this way we will just take various reading. Once we will take on 60 centimeter, another time we will take on 70, next time we will take on 80. Okay, so suppose time required for 10 oscillations is 10 seconds. Time required for 10 oscillations is 10 seconds. So 10 second is the time required for 10 oscillations. So 1 second will be time required for, just you will apply the unitary method and determine. Okay, just you will apply the unitary method and you will determine this time period. So 10 second is the, suppose 20 second you can take, now 20 second is the time period required for 10 oscillations. So within 1 second how many oscillations will take place? 10 upon 20, 10 upon 20 within 1 oscillation. So that gives us frequency. So opposite of that one will give us time period. So in this way we can determine the things, and we can make the graph. This t square value is determined to make the graph between this t square and this L, between this t square and L. So we will get the graph in this pattern, and we will get the equation t equals to 2 pi under root of L by G. T equals to 2 pi under root of L by G. So its proof and other things are not important for you. So just you should remember that time period, it is not in your syllabus. Time period equals to 2 pi. This proof and basic things we will study in class 12. So time period equals to 2 pi under root of L by G. That means you should remember one thing, that time period of a simple pendulum is directly proportional to the square root of the length, and time period of a simple pendulum is inversely proportional to the square root of the acceleration due to gravity. And one more thing is there, that is second pendulum. So second pendulum, it is a pendulum whose time period is 2 seconds and length is nearly 1 meter. So some simple numericals are there based on this, so that one you can solve it. And so this chapter first is over. Now we will discuss about the chapter second. So in the next class we will start chapter 2. So dear children, chapter 2 is motion in one dimension. So now we are stopping. So thank you.